Welcome back, everyone. We're about to take a deep dive into the mind of, well, a genius, Sir Isaac Newton. We're going to dig into some of his mathematical gems.
Oh, yeah, some real treasures buried in his work.
Exactly. And the best part, we'll discover how his insights from, like, centuries ago are still shaping our world today. Pretty cool, right?
Absolutely. It's amazing how relevant these ideas still are.
So to set the stage, we've got excerpts from some of his heavy hitters, a treatise of the system of the world, optics, even some personal letters. Plus, we've sprinkled in some historical accounts and, of course, some modern analysis. Helps put it all into perspective, you know?
Yeah, definitely. Context is key. And I think what's going to blow people's minds is how these mathematical concepts, which can seem, I don't know, kind of abstract, actually translate into real world stuff we experience every day.
That's what I'm really excited about. Like in his treatise, Newton talks about how Venus orbits the sun. But it's not just any orbit, it's practically a perfect circle. How did he even figure that out back then?
Well, that observation was like a cornerstone for one of Newton's most revolutionary ideas, the heliocentric model. Before Newton, the prevailing belief was that, Earth was the center of everything.
Ah, good old geocentrism. Everything revolves around us, right?
Exactly. But through his meticulous calculations and observations, Newton realized that, nope, it's the sun that's calling the shots. Planets, including our dear Earth, revolve around the sun. Big shift in thinking.
Huge. So just like today, where challenging assumptions helps us learn and grow, Newton's willingness to question, like the status quo, led to this massive leap forward in understanding our place in the cosmos. But he didn't stop at planets orbit the sun, did he?
Not a chance. He dove deep into the mechanics of how they orbit. He described how multiple bodies in space, planets, stars, they're all influenced by each other's gravity and actually orbit a common center of gravity.
So like imagine a cosmic dance, right?
Exactly. Think of like three celestial objects out there waltzing in space. They're not simply revolving around the biggest one. Instead, they're being pulled towards a point that represents their combined gravitational forces.
Whoa, that's a trippy way to picture it. A cosmic tug of war. And speaking of dances, we can't forget about the moon. It's got its own intricate waltz with gravity going on. I was reading that Newton figured out the moon's motion isn't just influenced by the Earth, but also by the sun's gravity. How's that work?
It's like the moon is being pulled in two directions at once, right? This dance of forces makes the moon's orbit a bit wobbly, not a perfect ellipse. And this phenomenon, it's not exclusive to our moon. The sun's gravity affects all the planets' orbits to some extent.
It's like the sun's this cosmic choreographer shaping all the planetary paths.
Pretty much. Now, think about this. Have you ever noticed how the tides are stronger at certain times of the month?
Oh yeah, definitely.
That, my friend, is Newton's work in action.
Really? But how does that tie back to gravity?
It all comes down to the sun and the moon's gravitational forces teaming up to create these patterns of high and low tides we see here on Earth. When the sun and moon are aligned, their forces combine, giving us stronger tides, called spring tides. And when they're at right angles, we get weaker tides, neap tides. It's a constant push and pull, this cosmic dance of gravity.
Wow, so those invisible forces are shaping our world in ways we can actually see and feel.
Absolutely. And what's mind-blowing is that Newton used a specific example from Batham, Vietnam. The tides there, they only happen once a day, all because of the moon's unique position relative to that location.
It's like this little cosmic quirk, and math can actually explain it. Amazing.
Right. One observation in Vietnam, and it reveals this incredible interconnectedness across the cosmos. Now let's talk about something that's always fascinated me. Comets. These celestial streaks, they're mesmerizing. And you guessed it, Newton cracked the code on why their tails always point away from the sun no matter which way they're traveling.
It's like they're running away from the sun, tail between their legs. So what's the secret?
Newton realized it was the sun's heat creating this sort of, I guess you could call it solar wind, that's constantly flowing outwards. This wind, it's a stream of charged particles, and it pushes the comet's tail, which is made of dust and gas, outward, always away from the sun. Imagine blowing on a dandelion, but on a cosmic scale.
I love that analogy. Okay, here's a detail I've always wondered about. Newton observed that comet tails are longer and brighter when they're moving away from the sun, like they're putting on a show as they make their exit. Why is that?
That's a great question. It's actually connected to Newton's calculations about how the air gets thinner the higher you go. The higher you go, the less air there is, almost like a vacuum. Comet tails, they behave similarly, becoming more spread out and brighter in this thinner environment as they move away from the sun's denser region.
So they're like cosmic fireworks, getting more spectacular the farther they travel.
You could say that. And here's another piece of the puzzle. Comets aren't just one-time visitors. Newton figured out that they travel in these predictable elliptical orbits around the sun, just like planets.
So they're part of the cosmic choreography too, following the rules of the solar system.
Precisely. His work on comets showed that these seemingly unpredictable objects actually follow the same laws of motion and gravity as the planets. A major step towards understanding just how unified and predictable the universe really is.
Okay, my mind is officially blown. But here's what really gets me. All of this isn't just some abstract knowledge, right? It has implications for how we live our lives today.
You're absolutely right. Want to find your way using GPS? Thank Newton.
Wait, what? Seriously?
I'm serious. We'll get into that after the break.
Our understanding of satellite orbits, which is, crucial for GPS, communication, Earth observation, it's all fundamentally based on Newton's work on gravity.
Wow. So every time we use GPS to find our way, we have Newton to thank. That's incredible.
Think about it. Newton's understanding of gravity lets us calculate how satellites are affected by Earth's gravitational pull. And that helps us predict their exact positions and use them to pinpoint our location. Mind-blowing. So those, abstract equations about gravity actually translate into something as practical as getting directions on our phones.
Exactly, and it doesn't stop there. The principles that Newton figured out about motion and forces, they help us understand how everything moves and interacts, whether it's, I don't know, a ball thrown in the air, a car speeding up, or a rocket blasting off into space.
So Newton was basically a rock star of science.
He was. But even rock stars have their moments of doubt, right?
I guess so. Even someone like Newton must have questioned things sometimes.
It's true. Even Newton had moments where he, wrestled with his own findings. For example, he really struggled with the idea of gravity extending infinitely throughout space. The whole philosophical and theological implications of an infinite force kind of freaked him out,
I can see why. Challenging those long-held beliefs can be, unsettling.
He was worried that maybe it would, diminish the role of God in the universe.
It must have been incredibly challenging to be, pioneering such revolutionary concepts. It's kind of comforting to know that even the greatest minds can experience doubt.
Right, for sure. It's a good reminder that wrestling with uncertainty, being okay with not knowing everything, it's often a key part of the scientific process.
Speaking of uncertainty, Newton didn't just explain why tides happen, he actually crunched the numbers to predict them. How did he even do that?
That's where Newton's math skills really shine. He developed what we call tidal theory, which basically allows us to predict when the tides will happen and how high they'll be in specific locations. And he took into account all sorts of things like the moon's phases, the sun's position, even the shape of the coastlines.
Wow, that's incredible. So he wasn't just gazing at the stars, he was creating tools that could actually be used by people.
Right. Sailors, coastal communities, anyone who needed to know about the ocean's ebb and flow.
It's amazing how scientific knowledge can be translated into these real-world benefits for society.
And it's still relevant today. Our understanding of tides, which builds on Newton's work, is essential for navigation, coastal engineering, understanding marine ecosystems. It's pretty remarkable.
It is. Speaking of practical applications, let's shift gears and talk about Newton's work with light. His experiments with prisms are, legendary. And it's not just about pretty rainbows, is it?
Not at all. Newton's experiments with prisms showed that white light is actually a blend of different colors, each with its own unique refrangibility.
Refrangibility, that's a mouthful.
Basically, it's the way light bends when it passes through something like a prism, and this bending separates the colors, giving us that spectrum.
Ah, so that's how we get those beautiful rainbow colors. It's like he unlocked nature's hidden code.
Exactly. And by understanding how light behaves, scientists could then create lenses that focus light more accurately, leading to clearer and more powerful instruments. Telescopes, microscopes, all thanks to Newton's insights.
So every time we see a mind-blowing image from the Hubble Space Telescope, we're seeing the results of Newton's work with prisms.
You got it. And think about photography. Newton's understanding of light and color, that was the foundation for how we capture and reproduce images today.
Wow. His impact is truly everywhere. And we can't forget about his contributions to, math itself. I'm talking about calculus, that thing that caused a lot of us to sweat through high school and college.
Yeah.
But seriously, why was it such a big deal?
Calculus was a game changer. It wasn't just some, abstract math concept. It provided a whole new way to describe change and motion with incredible precision. And this gave scientists this powerful new tool for modeling complex phenomena, things we couldn't really grasp before.
So even if most of us aren't using calculus every day, we're still reaping the benefits of all the cool stuff that was made possible because of it.
Definitely. It's a great example of how these seemingly abstract mathematical ideas can have a huge impact on our everyday world.
Okay, so we've covered a lot of ground here. Orbits, light, math. It's clear that Newton's work was, well, revolutionary. But there's one thing that still kind of bugs me. He basically solidified the idea that the sun is at the center of the solar system. But I read that he actually used both the geocentric the heliocentric models in his calculations. Isn't that kind of contradictory?
That's a really sharp observation, and it shows just how pragmatic Newton was. He understood that both models had their uses, depending on what problem he was trying to solve.
So he was adaptable, picking the right tool for the job, kind of like a cosmic handyman.
Exactly. While he was definitely a champion for the heliocentric model, he sometimes found it easier to use the Earth-centered view for, like, simplifying tricky calculations, especially when he was dealing with observations made from Earth.
That makes sense.
Yeah.
So what's the takeaway here?
It's a reminder that sometimes the newest, shiniest tool isn't always the best one for the job. It's about finding the approach that gives you the most accurate, the most insightful results. And sometimes that means being flexible and open to different perspectives. Don't be afraid to think outside the box.
Another great lesson. So it seems like Newton's work wasn't just about solving specific problems. It was about uncovering these fundamental principles that govern how the universe works.
Yeah, you got it. And those principles are still driving scientific exploration today. Newton showed us that there's this hidden mathematical beauty all around us. It's shaping everything. Tides, stars, even the technology in our pockets.
It really changes how you see the world, doesn't it?
Yeah.
It does. It's like I'm seeing everything with fresh eyes, like these hidden mathematical patterns are suddenly like popping out everywhere.
That's what happens when you start to grasp the fundamental principles behind, well, everything. It's like having this master key that unlocks all the secrets of nature.
And Newton, with his incredible mind and like insatiable curiosity, he was able to forge that key.
And the best part is, he didn't just keep it to himself. He shared his discoveries with the world. And he left behind this legacy of knowledge that continues to inspire us today.
It really makes you wonder, though, what other mysteries are still out there, just waiting to be uncovered? What new keys can we make using the tools and knowledge we have now?
I mean, think about it. If Newton could unlock these secrets centuries ago with, the limited tools he had, imagine what we can do today with all our fancy gadgets and knowledge.
It's almost overwhelming to think about all the possibilities, but it's exciting too.
It is exciting, and that's what I hope people listening take away from this deep dive. A sense of wonder, a spark of curiosity, that desire to explore the world with a newfound appreciation for the hidden mathematical beauty that's all around us, really.
You've definitely sparked that in me. I think you nailed it.
Yeah.
Whether we're looking up at the stars, checking out some new tech, or just observing the world around us, Newton's legacy reminds us that there's always more to learn, more to discover.
Exactly. And that pursuit of knowledge, it can lead to some extraordinary places. It can change how we understand the universe and our place in it.
Well said. So, to everyone listening out there, embrace that Newtonian spirit of curiosity. Who knows what amazing things you might find? Until next time, keep those minds curious and keep exploring.